Thank you very much for the introduction, and thanks to Quantarall, Anton, and all his staff for the invitation. It's a great pleasure to be here. So let's get going. What I want to talk about is the problem, or the problems, a range of problems that there are in actually building dApps that work on blockchains. Particularly, I'll talk about the Cardano blockchain, but it's a more general problem. If you look, a brief internet search unlocks a whole set of recent issues where large amounts of money have been lost. This is not, this is not a game. This is real stuff. So, the Ronin NetBridge exploit earlier this year lost $600 million worth of assets. Actually, that was a fairly traditional security hack. It involved the attackers breaking into a server. One server had all the information about passwords for a distributed set of servers, a consensus among which verified transactions in that algorithm. So it's fine to do distributed verification, consensus formation, but it's pretty silly to keep all your passwords on one particular server. So that's a traditional security hack, but has had huge consequences. Sorry, I need to work out which way the arrows go. And that was and it's interesting to see where that's happening. dApps are not simple things, and I'll come on to this point a bit later on in detail. But this was on a bridge between two blockchains. This was not something that was working on a single blockchain in a single language. It was about how you bridge assets from Ethereum to a more specialized blockchain. Bridges are becoming a more and more common technology, and they're a place where attacks take place. This is a really nice, aka nasty, example. Wormhole is another bridge technology, as far as I remember. The key point about this, it's an open source project, and they discovered they used the wrong function in an API. They'd used a function in an API which didn't have precisely the right security properties. They had fixed this and fixed it in their open GitHub repository. After it was fixed, an exploit took place because they fixed it, put it in their repo, but didn't deploy it immediately. So, a simple piece of process was enough to lose however much 120K equivalent Ether are worth. So again, perhaps a simple software engineering problem, but with huge financial consequences. One more example, Beanstalk. Again, here there was Beanstalk has a governance built into it. There are ways that you can change the behavior of algorithms by making a consensus among people with governance tokens. If you are able to embark on a flash loan, take a flash loan, buy enough governance tokens, perform the exploit. So again, that's at the level of social engineering. So we have one that's traditional security, we have one that is clearly related to open source deployment, and a final one that's related to engineering the economics inside a complex algorithm. So to summarize, what we have, and that's not to say anything about rug pulls. These are all situations where the developers were all good actors. There were bad actors out there, but not the developers. But of course, there can be situations where the developers themselves are bad actors. So, the world is a hostile place, particularly if what you're doing is deploying open source distributed algorithms out there. I mean, just to throw in some more figures, I think it is fair to say that DeFi is like the Wild West. There is little governance. There's little by way of certification, and so we have to trust. If we want to engage in this, we have to trust. We have to find ways of trusting. But it's clear that developers are losing out and customers of those developers are losing out. As far as the best estimates suggest that over $1 billion have been exploited in Web 3.0 vulnerabilities. And those tend to work in the area of DeFi because that's where the money is. That's where the value is sitting inside these algorithms. And 50% of those exploits are based on faulty code. I certainly know in cases within the Cardano ecosystem where calling the wrong function in an API has disastrous effects. You know, these are simple, they're not difficult problems, but they are manifestly problems that can be exploited. Centralization issues were the most common attack vector in 2021. I would bet, though it's not certain, it looks as though for 2022, bridges are the place. These are the places where technologies, there's a gap between the view on one blockchain, the view on another. There are potentials there for real exploitation. And certainly, the examples I've shown you are saying precisely that. Bridges are a common weakness. And this market is going to be growing. I mean, the figures here are smaller. These are the amounts of money that are being made by people developing smart contracts. You know, close to $1 billion is the estimate for later in the decade. But you can certainly see on a chain like Cardano, the numbers of DApps that are being deployed is huge. So this is not a problem that's going to be going away. People, unless something absolutely drastic happens, we will be working with DApps. People will be building DApps. And these exploits will continue. So that's the context in which we're working. And now I'm coming at this from a particularly a Cardano perspective, but I think a lot of the things that I'll say about, particularly about audit, the feedback we get from audit, applies to developers on any chain, whatever. So what's the technical challenge here? Just to remind you, I'm sure you know what's difficult. I go to this DApp, and it just presents to me as if it's a web page. I interact with web pages all the time. I talk to my bank and so on. I go to Amazon. What is it that makes DApps so vulnerable? Well, it's partly the programming model. It's more complicated programming on a blockchain than it is programming a centralized server. You're writing something in COBOL or Java. There are places you have to interact between what occurs on the blockchain and what occurs off the blockchain. Transactions have to be created and validated on chain. It's distributed, and we know the previous talk was talking about referring back to the literature there's been over the last 40 years of how to build secure systems in a distributed context. These are hard problems. And as I suggested in one of the examples earlier on, we've also got to think about ways in which the crypto economics is formulated. We assume, assumptions are made about how people behave, that are built into the way that certain sorts of behaviors are incentivized and certain sorts are not. But often there are assumptions that underlie those models, and those assumptions can be broken. If you can get hold of the majority of the keys for servers in a distributed consensus protocol, you've broken that assumption. If you're able to get flash loans, which allow you to buy a huge amount of assets for a very short period of time and exploit them, then that's broken the assumptions behind the governance protocol. And these structures also are based on social engineering. It's possible, and we know this from the non-crypto world, that it's possible to socially engineer exploits in all sorts of systems. So it isn't just a web page. It's a hugely complex system. And of course, just to be clear, we all know this, but it bears restating. There's an asymmetry in computer security. If you're a developer, what you aim to do is deliver the piece of functionality you've been asked to deliver. If you're a security consultant, a security engineer, you don't just look at how functionality is delivered. You look at all the possible ways that your functionality can be attacked. All an attacker needs is one exploit, whereas all that what the developer has to do is ensure there are no exploits. So it's like your house. The attacker just needs to be able to get in through one window, whereas you have to be sure that all the windows, you can't go in through the cellar, you can't socially engineer attack through the front door. You have to ensure that all those routes are safe. So this asymmetry of security is something that we have to live with. And it's clear that security isn't an add-on. This is a quote from a particular source, but we all know this. Again, I think this is not. I'm not saying anything, I hope, that's familiar, but it's just trying to set the scene for what we've been trying to do on one particular blockchain. It's not a matter of ticking boxes. It's a process, not a destination, if you like. Okay, so what can we try and do in the face of this, the history of exploits and the problems that we have in building these kind of applications? What we've tried to do on Cardano is do a number of things. We've tried to use mathematical proof. So all the protocols we use for consensus on Cardano, which is proof of stake based, are subject to mathematical verification. We peer-reviewed mathematical verification. We use robust programming approaches based on Haskell, based on functional programming, based on languages which allow us to do the right thing in terms of verification. And we use a sort of formal methods first approach. So we build specifications which we then implement. And this you can see particularly in the way that we worked with the ledger. We have a formal spec of the ledger rules which we then implement. But what we're trying to do now, and this is the narrowing in on what I want to talk about, is we're thinking now about ways in which we can encourage people to get their DApps certified, to think about increasing the assurance. We can't ever say, no guarantees can be provided here. If somebody says, I can guarantee your DApp won't be exploited, don't believe them. And what we've been looking at, and of course this is a sound approach in terms of security, we look at different approaches. No one approach is the right one. We need to look at different ways of providing assurance. But we also look at ways, and I think this is crucial, we look at ways of providing evidence to end users that a DApp has been certified. And I'll come on to that in a second. So what we've talked about is mechanisms for automated testing, mechanisms for doing in-depth audit, and we're looking also at ways that programs can be formally verified. We'll talk about each of those. And we're building a light wallet called Lace, inside which we're building a DApp store, and in that we have front and center certification. So when you look at a DApp in the DApp store, you get evidence of what forms of assurance you are guaranteed for this particular DApp. So we've taken this seriously. But please let me stress, it's not as if this isn't happening in other ecosystems, but we have been trying to emphasize it in our particular ecosystem. Okay, so that's been a general introduction to try and frame what I wanted to talk about. But let me say a tiny bit more about the technology, the technology here. When we start thinking about certification, it becomes important to think, what is a DApp? What really is a DApp? Well, I think one thing it's clear that a DApp is something like an app on your phone. If I go to the Apple App Store or the Google Play, what I do is I download code that I run on my phone. And so any process of certification for that, any process of trying to give assurance for that, involves looking at that code and saying, oh yeah, that code that I'm downloading onto my phone has the properties we want, meets these tests. That code is okay. When you interact with a DApp, it's not like that. What a DApp does, there will be flows of information flows of value from you into a program that is running. The way in which the values might move internally or outside the DApp are governed by inputs from oracles, choices made by users, and so on. But that code runs partly on blockchain, partly off. It runs by building transactions that are building transactions off-chain that's submitted to the chain and validated on-chain. So the model is not, here's the code in my phone. It's a much more complicated execution model. I interact usually with a web page, but that web page will initiate some off-chain code that will create transactions, and then these transactions are submitted, and potentially they are accepted or not on the blockchain. And so there are interactions between the on-chain and off-chain code. It's a complex thing. So when we're thinking, what do we mean by auditing a DApp, we have to think about what it means to be a DApp itself. Now, I've talked about this really earlier on, but when we're thinking about assurance, we've got to think there are multiple sorts of problem. Most of the problems I talked about at the beginning were problems of developers who were working in good faith. These developers doing what they thought was the right thing, but there were exploits available. But they can be malicious actors, and of course, when there are malicious actors, they can be outside, sitting there in North Korea or wherever, or they can be inside your organization. And that's always the most difficult, somebody building trapdoors or whatever into complex dApps. So we have to think about those different angles. I should have said earlier on, if you want more details about any of those particular case studies I talked about at the beginning, I tweeted links to the analyses on the web on my Twitter account, which is Thompson_Sci. So I did that earlier this morning. So if you want to follow up on any of those, the information is there. So we talked about the actors. We've got to think about assuring different kinds of things. Do we just assure the code that runs on the blockchain, or do we think about the off-chain code? Do we think about complete systems? Do we think about crypto economics? When we provide assurance, what is it that we assure? We can assure different kinds of things. And then when we start looking at assurance, there are different kinds of things we can do. We can do testing. We can provide, we can, we are right. We can provide tests. We can do modeling. We can do, I think there's a slide missing here, but never mind, that's my own fault. So we can test, we can do what's called, model checking. We can look at things like property-based testing, and we can look at verification. Apologies, I don't know how I lost the slide there, but never mind. But each of those things produces evidence. When we run tests, we get test results. When we do property-based testing, we have models, we have transcripts of the testing that's taken place. When we do model checking, we have potential counterexamples. When we do proof, we get proof. So each of these kinds of mechanisms gives us evidence. And what we want to do is ensure that that evidence is stored in some way as metadata on the blockchain, so that we can say, this DApp has this evidence that it is assured. And so what we're trying to do is close that loop to make sure that not only are we making claims about DApps being assured, but we're providing evidence that that's the case. Now, you might say, but how do we build the link? What is it that we what is it that we link to? As I said, we've got this distributed application. What is it that we link to when we make that claim? Is it the whole code, or is it the deployed online? And I think what we're, in the end, if you want to identify the identity of a DApp, it is the code that runs on the blockchain. It has to be that. Certainly in the case of Cardano. This is, but I think in every case, the DApp is identified by the scripts, by the contracts that sit on the blockchain. That, in the end, because that's the only thing I can have a handle on. I can't have a handle on the design of a web page or whatever. The design of the web page through which I interact with the blockchain is irrelevant. What's relevant is the scripts, the contracts that are running on the chain. And just missing that. How is it that we build, how is it that we can identify, we can be sure that when we interact with a DApp, we're interacting with the scripts, with the contracts that we have to, we expect to? The answer is the place that we do it is through our wallet. Because that's the place in the end that we approve transactions. So when we approve a transaction, when we sign a transaction, that's the place that we can take the step and say, is this transaction being submitted to the right code? So that is the point where we can say, yes, you're safe. We can see, my wallet can see that there is metadata that asserts that the contracts that this is being submitted to have the property they require. So this is the loop that we want to, this is the circle we want to close. We want to be able to say to users, not just say in a DApp store, this is certified, but not being clear what is certified. We can say this is certified, and moreover, when you use this wallet to talk to this DApp, you will be able to check that when you submit a transaction, it is being submitted to contracts that are certified. And you can, and that will allow you, your wallet will take you to the metadata that is attested by the auditor or whatever to give you that assurance. So we can build, I was saying 5 minutes ago or so, it's relatively easy with an app store. You download code, and that's the code that you're running on your phone. Fine. With this, it's more complicated, but we can, in a wallet, say, is this transaction being submitted to a certified application? Okay. So what is it that we're doing? What will our certificates look like? What we're doing at the moment, obviously it's possible to do unit tests on dApps, and that's fine. That's perfectly good. What we're trying to do is enhance that and allow for what's called property-based testing. If you're familiar with Haskell, you'll be familiar with QuickCheck. So we're working with Cuvic, who are the company who ultimately were behind QuickCheck, to do what's called model-driven testing. So you build a model of what your DApp should do, and then you test the real DApp according to what the behaviors that the model suggests. Oops, sorry, wrong arrow. So for example, once a model is built, you can check a key property for a DApp is that funds can be recovered from it. You know, I was reading it, there's an exploit published earlier this week about a DApp. A developer had wanted to suspend an old version of a contract to replace it with a new one. What they did instead was close the contract down and lock $100 million worth of funds in that contract, just by using the wrong command. What we can do here is, using this model, we can analyze whether or not it's possible to rescue funds from a contract at any point during its execution. And what the developer does is say, yes, here's the way to do it, and what the probability-based testing does is try out that scenario in multiple different situations. And so it allows you to exercise a whole lot of randomly generated scenarios to see whether or not you can always rescue those funds. So that's the support we're getting there. It's possible to look, for example, for resilience to off-chain failure. That's another property we can check for. And the QVIC, our collaboration with QVIC at the moment is now developing a way of writing threat models for DApps using the same approach. So saying we can see a range of threats of this kind expressed in this way inside the model. Can you test for those? So that you're allowed proactively to do your own threat modeling. Now, of course, this presupposes the developer is working in good faith, but that's what's happening. These are where the exploits lie quite often. So this allows us to do that. Okay, how am I doing for time? What we're doing, the second thing we're doing, and I will dwell on a few particular points here. We're stressing the value of audit for DApps built on Cardano. We're working with a number of auditors. We built a CIP, a Cardano Improvement Standard, for best practice for audit for DApps on Cardano. And we've gained a whole lot of insights into there's another missing slide. Never mind. A whole lot of insights into the audit process. So, for example, Pi Lanningham, who was behind one of the major Sunday Swap, which is a major DEX on Cardano, he was saying to me now, people are beginning to expect that, the community are beginning to expect that audit will take place. An expectation, if that happens, that raises the standards of all the DApps being developed on Cardano. And again, another Evercrypt DAO, I think they've talked about the value of open information, the value of openness in building audits. Some particular feedback from a number of the auditors: we always find something. No auditor says we never find a problem. Having a new set of eyes on your code makes perfect sense. They said there's a close correlation between the methodology of the team. Do your team work well? Is it a functional rather than a dysfunctional organization? That will be reflected in the quality of the code that's produced. And I think the point here, it's a small point right at the bottom of the slide. Smart contracts are the killer application for formal verification. Why is that? The answer is because they're relatively small programs which embody huge amounts of value. We've seen the sorts of figures I talked about at the beginning. And a smart contract typically will be a small piece of code. It's not like verifying an operating system. It's perhaps hundreds or thousands at most of lines. Doing formal verification on that is feasible, and the cost benefit there can be huge. Interesting exploits on Cardano that have been identified. A weak point is often the way in which tokens are minted or burnt. If tokens are often used as a way of expressing ownership of something, and if a token that should be unique can be replicated, then clearly there are exploits to be had there. And we've seen this in practice. We've seen issues about disconnects between on-chain code and off-chain code. One team does the on-chain code, another does the off-chain code. There is a mismatch between the perceptions of those two teams. That's a place for exploits. And I mean, again, it's classic software engineering. Optimizations can be a place that vulnerabilities get introduced. You get it right, and it's too slow, so you optimize, and thereby you introduce a vulnerability. There are a number of examples we've seen where that's been the case. So, classic advice, I think, there. And another piece of advice from Pi Lanningham, saying the process of audit is not something that's ever finished. you're never at the point where you can say 100% of bugs have been eliminated. And companies saying it's good to start early. Start your audit from the earliest possible point. Start at the design stage. We've seen evidence where audits at the design stage have helped people to avoid design faults, which it's so much harder to rectify when you get to implementation. And I think transaction building is not simple. Off-chain components and centralized. We've seen these. I've talked about these things earlier on. And we've also seen cases where the community has rescued. Somebody has published a flawed open source code, and another member of the community, a potential competitor, has spotted that and has done fair disclosure, talking to the developer, saying, "Look, here is an exploit." So open source, publishing open source can be a way of improving improving the visibility of your code and thereby allowing exploits to be identified. Now that can be good if it's done by somebody who is going to notify you. It's not good if they're not. So there's a trade-off there. And we've got an example where CertiK, one of the auditors in the Cardano space, have done a nice piece of work, doing some formal verification, doing some proof to ensure that a key property of the DApp is, a key property of the system is an invariant. And they've done that again, based on the fact that the code they're verifying is relatively small scale. Okay, so let me wrap up. Let me say what we've done. What we've done is build these best practice guidelines, talking to DApp developers, talking to auditors, and I see that Ethereum have just published a similar set of guidelines recently. So this is becoming standard across different blockchains, raising the standard of what's expected from developers. And it talks about the process, it talks about requirements on auditors, it gives a timeline on what audits should look like. We've also identified a set of common weaknesses, and that's growing. We're building that as we speak. And then next steps, what are we doing? What we're aiming to do is to provide the QVIC testing approach as a service. We're doing that at the moment. That should be coming in the next month or so. What we're doing is working with the team who are building the DApp store to build a standard for online certification metadata, on-chain certification metadata, and then when we have that, we will integrate with the DApp store on its launch. And so what we're aiming to do there is to make sure when you go to a DApp in the DApp store, if it's audited, you can, through the DApp store, go directly to a secure link to the audit report. The full report. Because do you know what? Sometimes if people publish audit reports on their own websites, they remove certain parts of them. This will be sure that this will go to the full audit report as certified by the auditor. And we're looking at building a community-based certification initiative to build on what we saw earlier with the wing riders. And we're looking at ways that we can extend the specification and verification field inside Cardano. So I think it's partly a statement of intent. We're saying this is what we're intending to do, but also saying this is where we are with audit and sharing with you the insights that we've had from talking to auditors, encouraging audit across the Cardano ecosystem. So I think that's it from me. But any questions? Okay.
Hi.
Hi.
I have too many questions for you, but I'll just ask one. So you're saying that the best way to secure an application is to go through your certification process. But I want to challenge that and ask you, don't you think that the best security is the time and beta testing the applications? Because just putting a batch on an application doesn't mean that the application is secure. And
No, putting a badge doesn't make it secure, but I think it makes it no less secure than it was without. And I think it's this idea of a new set of eyes on something. You know, if you go to somebody else's code, you can sometimes spot a problem that you just didn't see because it's so obvious. And we see this all the time. We've seen this anecdotally. If you call the wrong function in an API, you're not thinking about that. When you see that in your code, you think it's doing what it's supposed to do. It's got the right name, because often APIs don't use the right naming. They don't distinguish similar functions in the right way. And it's something that you just don't see. An extra set of eyes will potentially see that. It won't necessarily. But yeah, I don't see anything to be gained by not doing it. Yeah.
Yeah, thank you. Another question, maybe in the similar direction. What about upgradable applications and contracts?
Upgradable?
Yeah, there is this practice of introducing proxies, and what sort of other ways to introduce like upgradability patterns in your application. So how do you assure the user is interacting actually with the code that they've seen, like in a repo somewhere?
Well, I think that's what I was saying, that this is something that you can do and only do in the wallet. So at that point, if what you do is you attach the certificate effectively to the code that's running on chain. Okay, but you're saying you can't pin that down.
Yeah, if this is if there is a proxy standing between you and the contract that you are to interact with, then I don't know, how do you assure that the proxy is not calling another contract?
That's a good question. You know, I'm not I can't make everything work. But then that's a problem. Should you use an application that works in that way? Okay, it's the whole security question. It's affordance versus security, right? And in some ways, you could say that having upgradability is a good thing because you can fix bugs. So that, potentially that's good. But it's not. It means then that the assurance you get from a system is that much lower. I mean, I think that having the fact of talking about this makes people think about that dimension. I mean, clearly, if you like, programmers are always going to think they always want their life to be easy. You want to be able to do as much as you can as easily as possible. Whereas security people say, no, you can't do that. Because if you do that, I can't guarantee this. So there's always going to be that trade-off. And I don't think, it's not something we can solve, but I think it's something that if you're thinking seriously about security, you might worry about. Because people do deploy whatever, even if you're entirely working in good faith, people sometimes deploy buggy programs, and you do that. If you do it that way, you could easily introduce an exploit. Whereas if the discipline you have is to not to use that sort of proxy, then you can't do that sort of lazy upgrade.
Thanks.
I think that's it. It's just that's the world.
Hey. So,
all right.
Yeah, here.
Oh, yeah, right.
Two short questions. First one is, I guess this, I assume that the certification actually implies that the contract code is open source and not closed source. I'm not very familiar with Cardano, but yeah, on most blockchains you can just publish the not the source code, but the VM code. That's the first question.
Yeah, I think you can do. It depends. I mean, again, this is because it's security. There are questions of trust, and here, if there is an auditor involved, and you trust the auditor, then you can potentially trust the fact that they have said that this code, which you can see but you can't see the source of, but this particular artifact is audited, then that's fine. So you're not requiring open source for the audit side of things. I think for testing, it's going to be open source because you require the source code to perform the tests usually.
Yeah. I guess with property-based testing, you just need the interface, but yeah.
Well, yeah.
So that leads to my second question. Don't you think that this certification and the App Store specifically adds a single point of censorship and kind of loses the point of trustless idea of blockchains?
No. The reason that the DApp Store hasn't appeared, and it's a bit of a frustration to me personally because I wanted to see it appear, is that we've gone for an architecture which says all the information on which the DApp Store is based is published on the blockchain.
Yeah, but you have to trust the publisher then.
You have to?
You have to trust the publisher of that information.
Well, the publisher is the right, okay, but you have to trust somebody, right?
Right.
So the solution,
Yeah.
the solution we've gone for is to use DIDs, so distributed identifiers, and there's a question about, do you trust auditors for publishing audit reports? Well, I guess you do. There's then the question about how you identify clearly who is the author of a DApp, and that is again that's a question that we've had, I've not personally, but we've had to grapple with as an organisation, because if you do go for totally decentralized identity, it's a problem about how you bootstrap that. So there have to be sources of trust somewhere, But the point is that this is being done in a way that no censorship is performed by so anyone can replicate the DApp Store because it's based on information that is published on chain.
Okay.
And that was a design decision, and it's made things more complicated, but it was a decision we took.
Okay, thank you.
There's one question over there, I think, but I don't know whether we need to finish. I don't know. I'm happy to talk. Oh.
Thank you. Thank you for the nice lecture. I just want to ask you, do you envision that certification of dApps like a one-way certificate or multi-level certificates?
I think I see it as multi-dimensional, that you could certify different kinds of testing. It's really about recording evidence of different processes on blockchain. So you can do property-based testing, but there's also other approaches coming from other people in the ecosystem about doing different kinds of testing. You can imagine different kinds of proof. You can imagine different auditors performing the same audit. So I think the short answer is the more information, the better, because it provides a broader range of assurance. So yeah, not just one, but many. Okay. I'm going to stop. So thank you.